All right, folks, welcome back. Day 2 of section 11.2. We've multiplied, now we're dividing, which is nice because division and multiplication when it comes to fractions, not a whole lot different. There's a slightly different concept that's at work. Also, I'm kind of playing around with this feature. Hello, everyone. Picture in picture. I won't make you stare at me too much, but it's nice to see my students, especially when we're on this little hiatus. So let's get to it. So problem 4, and this is again kind of the second half of section 11.2. We're going to divide some rational expressions, and big thing, division and multiplication, they differ in the sense that when we divide, it's equivalent to multiplying by the reciprocal. So, and throughout this entire unit, I know you guys are probably beating your head against the wall thinking, why are we doing this? Well, we're really just getting very, very deep into the concept of what fractions are and what our operations are. So you're getting into the discipline of math a little bit more in depth with this unit, which hopefully you guys are enjoying. I know some of you guys are probably thinking, man, Neubauer, these expressions are complicated. Well, yeah, they are. You guys are in an advanced class, and we're getting towards some advanced concepts. But they really come back to some basic concepts. Any fraction can be divided by multiplying by the reciprocal of that fraction. Okay, so this is equivalent to d over c. Well, easy enough. We've got a times d on top over b times c on bottom. So the concepts are consistent. Right? When we're dealing with more complicated expressions, it's just you're having to do a little bit more with them. So we're going to continue on. Here's our first example problem. We're looking for the quotient of these two expressions. Now, a couple things that you guys are looking for. Number one is if you can factor, you should. All right? Factoring always makes the problem easier. So when I look at x squared minus 25, I know that x squared is a perfect square and 25 is a perfect square, which means that this expression can be changed. And what I'm going to change that to is an equivalent expression of x plus 5 multiplied by x minus 5. All right? If you guys think back to chapter, I think it was 8, when we were factoring these, this is the difference of squares where those middle terms in the FOILing process would cancel. So that's an equivalent way of writing it. On bottom, okay, we want to think to ourselves, can 4x plus 28 simplify to anything different? Well, both 4 and 28 contain a common factor of 4, so I'm just going to divide out that 4 and see if that makes my problem a little bit easier. 4 multiplied by the expression x plus 7 would be equivalent. All right, that's an equivalent expression. Now, when we divide, right, remember this is a process of multiplying by the reciprocal, so we're going to flip this thing. And the other thing to consider is, since we do have a trinomial in the basement of this one, is can we factor that trinomial? Can we factor x squared plus 9x plus 14 down to something different that potentially could help with canceling? Well, when we factor this, hopefully you guys are getting practice with that, we need factors of 14. So let's go and list them. 1 and 14, 2 and 7. That would also add to the number 9. Well, I think I found my answer right here in 2 and 7. So what I will do is write this as a different form on top. This is going to be multiplied by this expression, x plus 2, multiplied by x plus 7. Remember, that's no different, right? That's the exact same expression. It's just written in a different way. This is all over. Now x minus 5 is put in the basement, so we've got x minus 5 downstairs. Next thing, as you guys are probably used to, is we're looking for cancellations. And hopefully you guys are looking at this saying, hey, there's an x minus 5 in the bottom. There's an x minus 5 on top. Those would cancel. And if you think about it, there's also x plus 7 upstairs. There's x plus 7 in the numerator. There's x plus 7 in the denominator. Those would also cancel. And now as we look at this, we've only got x plus 5 and x plus 2 on top, so let's write that out, x plus 5 and x plus 2. And then on the bottom is just the number 4. Now, some of you guys might have been thinking to yourself in yesterday's lesson, how do I know if I'm done? How do I know if my answer is my answer? And a good way of thinking about that is, if the numerator and the denominator are factorable, you should try and factor them, okay, and see if anything else cancels. But when I look at this, x plus 5 and x plus 2, that doesn't factor down to anything different. The number 4 doesn't factor down to anything different. and I don't have any excluded values. This is my answer. This is a simplified version of that division. This is all the further that we need to go. Alright, so we're going to try a couple other examples here, see what we can do with them. So this is example B. X over x plus y divided by xy over x plus y. So again, first step, since we are dividing, we're going to multiply by the reciprocal. Look for things to factor. With this one, I don't see any numbers, so I'm not really thinking that anything will factor on this problem. So I'm just going to write it out. X over x plus y multiplied by x plus y over xy. Well, as you see this, we've got x plus y upstairs, x plus y downstairs. Cancel them. Those are gone. Right? And we just write our answer out as x over xy. Well, do you guys think, if you think to yourself here, we've got x over xy, the x's will cancel, and there is always that imaginary number 1 in front of there. So if we cancel x's here, this actually reduces, even though it's kind of a complex problem, down just to the example 1 over y. And that's it. 1 over y. Next problem. Problem C. If you guys would like to, you can write it down and attempt to get going with it and attempt to factor it, or attempt to simplify it. But again, as I see this, you want to think, can I factor anything first? Well, I'm going to start with my 4k plus 8. 4k and 8 both have common factors of 4, so I'm going to write that out. 4 multiplied by the expression k plus 2. The bottom expression, 6k minus 10. Well, 6 and 10 both share a common factor of 2, so I'm going to factor out the 2 multiplied by k minus 5. Now, if you guys really think about this, 4 over 2, that just reduces to 2 over 1. So we can write that out as just 2 over 1, cancel this, and create this into a 2. And now all of a sudden my problem is just a little bit easier. Now, since we are dividing, we're going to flip-flop these two. All right. The other thing to consider is, what would 9k minus 15 be when factored? So we're thinking, what are factors of 9 and 15 that we could pull out? Well, 9 is divisible by 3, 15 is divisible by 3, so let's write it this way.
Good morning, staff.
You guys get a little update from Mr. Voce.
Trying to get into the Zoom meeting here. Some of you I see are in there. We're trying to just figure out a few things, so it's just going to take a little bit. So be patient. And also, if you have not seen your email in the last 10 minutes, then you probably want to click on there. There will be a link to join the meeting.
Little update from our fearless leader, Mr. Voce. 3, now 9k minus 15, when we divide out the factor of 3, we would get 3k minus 5. Now on bottom here, on the top, when we look at k squared plus 6k plus 8, so k squared plus 6k plus 8, well, we're thinking factors of 8 that would also add to 6. So I want to say that this will factor to k plus 2 times k plus 4. So I'm going to write that in the basement here. Over k plus 2 and k plus 4. And now again, what we're looking for is anything that potentially could simplify, right? And with this problem, I see k plus 2, basement and on top, so I'm going to cancel that one off. And I don't believe I've got just about anything else that would simplify here. Now, I am realizing I made a mistake here as well. I should have a 3k in front of this. When you divide 6k and 10 by 2, it wouldn't be k minus 5, it would be 3k minus 5. So caught that error. Hopefully I thought something wasn't working out there. But now you can see actually that 3k minus 5 and 3k minus 5 will also cancel. So now what I'm left with is I got the number 2 times the number 3. Well, 2 times the number 3 is left on top. On bottom, this is gone, this is gone, this is gone. K plus 4 remains, so we got k plus 4. Well, that simplifies just to the 6 over k plus 4. And again, for our checkpoint is we're thinking, can the numerator or the denominator factor any further than they already are? And in this situation, they can't. The 6 over k plus 4. 6 doesn't factor, k plus 4 doesn't factor. The only thing that we would have to do is make sure that we add the disclaimer that k cannot be equal to negative 4. That would make a 0 in the bottom. So quite the process. But again, division and multiplication, very similar. Division just requires you to multiply by the reciprocal. Now, moving on, problem 5. Okay, we're going to find the quotient of this expression divided by x squared minus 3x minus 4. This is a little bit tough to read here, but that is a division symbol there. Now, you may be thinking to yourself, what's the reciprocal of this? Well, the reciprocal of a polynomial is just 1 over the polynomial. So we're going to write this again, and we're going to write it out as 3x squared minus 12x. And I'm going to also try and factor this first, because remember, factoring helps us to cancel things. So this could be rewritten as 3x multiplied by x minus 4. Okay, and all I did again was divided out the factor of 3x in both of those terms. I'm going to put that over 5x. And then I'm going to multiply by the reciprocal of this. Well, the reciprocal of this would be 1 over that expression. And the other thing we want to think about is, does the expression actually factor? Well, let's fill it out. Let's figure out if it does factor. We need multiples of negative 4, or something that multiplies to negative 4. Well, that's 1, 4, and 2 and 2. And we want to think of, do any of those also add to a negative 3? And I think in this case they will. This would factor to the expression x plus 1 multiplied by x minus 4. Alright, and now we can start to eliminate stuff if we want to, or if we can. And I think in this case we can. We've got x minus 4 on the bottom. We've got x minus 4 on the top. Those would cancel. So now what we're left with is just 3x times 1 on top over 5x times the expression x plus 1 on the bottom. And now we can see that x's might cancel here, so we could cancel this x and cancel this x, and that's just leaving us with 3 on top over 5 times the expression x plus 1. Okay, top can't factor, bottom can't factor. X cannot be equal to negative 1. That's our only other disclaimer, and we're done. Now, last example we're going to work through today is the idea of a complex fraction, which complex fraction by definition is, if you guys don't like fractions, this is probably not your bag, but a fraction that contains more than one fraction in its numerator, denominator, or both. So this is an example, and these are, again, we're getting into the discipline of math here. 1 over x minus 2 divided by or over x plus 3 over x squared minus 4. So I'm going to write it in this different way. 1 over x minus 2 divided by x plus 3 over x squared minus 4. Remember, division or a fraction, they're kind of the same thing. They represent similar ideas. So this is what we have here. Now I'm going to, there we go. Now again, dividing, same as multiplying by the reciprocal. So we're going to write this out. 1 over x minus 2 multiplied by, this expression is now going to move to the top. This expression is going to move to the bottom. Remembering that if we can factor it, we should. X squared minus 4, that's a difference of squares. So this is x plus 2 multiplied by x minus 2. These are equivalent. Over x plus 3. Look for anything that would cancel. Well, we've got x minus 2 on top, x minus 2 on bottom. And the only thing that's left here is 1 times this. Well, that's just x plus 2. And on bottom is basically 1 times this expression, x plus 3. And if we can factor the top or the bottom and cancel anything, we should. But I don't think we can. This is our answer. The only value that can't be included in this is x cannot be equal to negative 3. Alright guys, hopefully you found this helpful. Enjoy your practice.